Hello, in this episode we're going to talk about amp reading with different meters, how we go about the technology that's used, and the best choice that you may have in your toolbox or plan on purchasing in the future. There's three main technologies that we are going to have access to. One is going to be external shunt style current testing adapter. I guess we'll use the word adapter. Next one is going to be the internal shunt or Hall, depending on the configuration, internally within your meter. And last is going to be an external Hall Effect Amprobe, or the older style were an induction coil. Virtually all the new ones are going to be a Hall Effect configuration. So let's get started here, and we'll cover it kind of in the order I've laid out. So the first one we're going to look at is the old-fashioned MT500. This is an item that came with the tool, so it was one of the accessories that you would get with it. So you could use this on any style meter, but in this particular case we're going to go ahead and show it in its original configuration. So the meter came with the shunt. It was stored inside the storage box, and it's a relatively simple design. What we're going to do here is we're going to hook up and we're going to push current through the two high current alligator connections. So I have just an old-fashioned headlight. It's going to draw about 3.5 amps. So we're going to hook up here, and then coming off of my power supply, we'll make our hook up there to the positive side. So polarity sensitive. I'm going to turn on the meter. I made up some custom leads, but you can use anything you want. It come with these regular spade connectors, a female spade. Plug in the positive side of the voltmeter, and then we're going to plug in the negative side of the voltmeter. And we see at this point here we have 0 volts. I'll go ahead and switch on my power supply. And at this point here we have 3.3, it's displaying 3.3 amps are flowing through the headlight. That current is coming through the shunt, and we're measuring the voltage drop between these 2 points. So that's kind of the concept behind it, is measuring the voltage drop between these 2 points. And it's a calibrated, so you can see here in this particular case we're in a millivolt scale, so we're at a scale here of 300 millivolts, or 200 millivolts, excuse me, and we are seeing 3.3, so that equates out, doing the math on it, into 3.3 amps. I want you to take note of something here. I'm going to turn this off again, turn it back on, and for a moment you saw a lot more current. Remember, that's called inrush current. We'll talk about this with the other ones also. If you ohmed out that light bulb, you would find it be almost a dead short. Once you apply power, the element heats up, of course, changes the resistance. So classic Ohm's law. So that is the process here of hooking this up. So you're basically pulling the circuit. So anything you'd be hooking up to, you would actually put this in series. But it is limited, but is not fused, meaning this is only intended to draw 50 amps. It has a nice purpose because it works in that higher current range where not so easy to work with your regular DVOM. So that is the process for that particular hookup. Okay, in the next hookup, we're going to go ahead and use the amp section of the DVOM. So we have our common and our amps. Your meter may be different, but it's all going to be the same kind of methodology. Since we know we're going to be dealing with a little higher current, I'm going to work in the standard amps range. So now I've got it turned on. I'm hooked up, so the current is going to want to flow through here. We'll turn our power off. I'm going to hook in here, supplying power. So that's a banana plug that I plugged into earlier and are hooked up to, and this is going to be our ground, and our ground is going to be where the load is located. So we're going to go ahead and we're going to turn on the power. And we see here we have 3.5 amps. Now this is, by levels of magnitude, the most accurate way to measure. So all I've done is I've hooked up in a series circuit, so power's coming out here to this lead, to this one, being completed through the meter itself, out to my load, in this case here being the light bulb. Let's turn it on and off one more time. And just observe the inrush current. So again, you're seeing that. It came in, there was an inrush current, and we saw both. We had to put it on a peak hold, we could see what the maximum inrush current. For the demonstration here today, I just wanted to show the basic hookup. So this basic hookup is such that we just simply go into the common and amps. So here again, completing the series circuit, just to reiterate my point. In this next section, we're going to demonstrate the low amps probe. So how this works is we're going to have our meter set up. It's going to send in a millivolt signal. I am going to go at the 20 amp range. Let's turn off our power here. I'm going to go at the 20 amp range. I'm going to turn it over there, and I'm going to go ahead and I'm going to zero the meter out. Now we'll hook it around here and turn it on. And you can see this is showing us that we have 300 or 3.8. So you remember you got to do the conversion here. So we've got 3.8 amps. We'll move the range over. So as you get up more sensitivity on the meter, the slightest movement here is going to cause it to change. So we're seeing 3.8. So we do have some inconsistencies to be expected. That's how this world works. So the most accurate way of measuring is your internal shunt. The second most accurate way, I would have to say, is going to be an external shunt. The least accurate but most convenient is going to be your Hall Effect style current probe. And what we have here is a magnetic field that's formed around the wire that is converted here into an electrical signal and outputted. So the three different methodologies. So let's look at that inrush current, see what we see there. It jumped up, it jumps around, takes a little longer to stabilize than you have with the internal meter. So three different ways. We'll go to the next slide here. The two external styles, so our shunt, in this case here, and our Hall Effect, both require you to do a little bit of math. Now as you get into some of the more advanced meters and scopes, they do have a function that gives you that calculations already built in. Most of the time that is not the case. No worry, you can simply work the numbers out. It's really obvious and relative. The direct reading, of course, is the best, but my experience over the years as an educator and doing research work and such, I found a lot of technicians are trying to measure current with a blown fuse. In a future episode, we're going to go into that in great depth, but remember, check that fuse. Because you'll see something here, it's just going to be the ether, it's going to be the noise running in the background, giving you information that is going to be a problem, ultimately, in your diagnosis. So again, make sure this is the best methodology, is the internal style, my opinion. Second. Third, most convenient. maybe secondarily most convenient because it can take a lot of current. You put it across a larger fuse and get it. The least convenient, but most accurate. So you see it's give and take, or pros and cons of each methodology. So keep each one of the methods in mind as you go forward, and either make a purchase, hopefully utilize the equipment that you have now more efficiently. Well, I want to thank you for your time. I hope you learned something. Please rate and subscribe, and I thank you.